In this video, we're going to do some examples of fitting models to data. In our first example, it says the table shows the yield Y in milligrams of a chemical reaction after X minutes. Use a graphing utility to find a logarithmic model and a linear model. So we're finding a logarithmic and a linear model for the data and identifying the correlation of determination for each model. Then we're going to determine which model will fit that data better. So I'm going to have you go ahead and go into your calculator, and you're going to go to, let me move this over a little bit. We're going to go to Stat, Edit, and then you're going to enter in your data points into the calculator, like I've already done here. So X is in the L1 and Y is in the L2. So go ahead and push pause and do that. When you're done, push play, and we'll go from there. So once we have that, we're going to calculate our logarithmic and our linear models. So to do that, we're going to go to Stat, arrow over to Calculate, and we'll do our logarithmic model first. So we'll come down till we get to the natural regression. So that's our logarithmic model. And so we're going to go ahead and hit Enter. And we have list 1 and list 2. And as long as you have your stats diagnostics turned on, then that should be fine. If not, just hit Mode and go down and turn it on. And so here we go, we've calculated it out. And so we can go ahead and we can write our logarithmic model. And don't forget to write down your R squared value, which is your correlation determination. So we have Y equals 1.538 plus 8.737 times the natural log of X with an R squared value of 0.9935. So we want to calculate our linear model. So we're going to go ahead and we're going to go to Stat, Calculate. We'll go down to Linear Model, which is option 4. Hit Enter and have it calculate that for us. And so we have these values, our A, B, and our R squared. So go ahead and write down that model. So here we have Y equals 2.29x plus 2.3 with an R squared value of 0.9010. So which model would fit the data better? That's right. It's going to be our logarithmic model. And the reason it's our logarithmic model is because our R squared is closer to 1 than our R squared for the linear model is. Let's do another example. So in this example, we've got that a table shows the amount Y in grams of a radioactive substance remaining after X days. And we're going to use a graphing utility to find a model for the data. And then we want to know how much of that substance is going to remain after 15 days. So we want to begin by putting in our table into our graphing calculator. So we're going to go to Stat, Edit, clear your old lists. Then we're going to put our new values in. So our X's will be our list 1 and our Y's will be our list 2. So go ahead and push pause, and when you're done with that, push play, and we'll go from there. Now that our data has been entered into our calculator, we're going to want to look at the scatter plot. So we're going to go to our window and adjust our window. So we're going to go from 0 to, our maximum was 10, so maybe let's do 15. And then our Y's, let's see, well, I guess technically we had an 8. We'll go to 15 anyways, it won't hurt us. And then our Y value, we had a minimum of 0 and a maximum of 12. That should be fine as well. So we're going to turn on our first stat plot. So we're going to go on, we're going to turn it on. And we're going to say, okay, we want list 1 and list 2 because that's where our data is. And then we're going to hit graph. And here we see our stat plot for our data. So it doesn't really look like a linear model would really be great here. So from our scatter plot, it appears that maybe an exponential model is going to be a good fit. So we're going to use the regression feature of our graphing utility to find the exponential model. So we're going to go to Stat, Calculate, and we're going to arrow down to Exponential Model. So exponential regression, option 0. And we're saying list 1 and list 2. We're going to have it calculate. Make sure it calculates your R squared as well. Let's go ahead and let's write that model down. So now we want to check our model and make sure that it looks good. So we're going to have Y equals 10.08 times 0.877x, or raised to the x rather, and we're going to put that into the Y equals of our calculator. When we're done, when we hit graph, we see that it goes through those points really well. And that makes sense because our R squared value, or our correlation of determination, is 0.9988, which is extremely close to 1. which tells us that this is going to be a good fit for our data set. So because it wants x equals 15, we can plug that 15 in, and we can either plug the whole thing into the calculator, or we can open up the table feature of our calculator, and we can scroll down to the number 15, and here we see we have an answer of 1.4075. So that means approximately 1.4 grams is going to be, oops. Now there might be times where you're asked to change that model to a natural exponential model. So by changing that model right there. So I'm going to go over really quickly how to do that. Basically, all you're going to do is you're going to take that original equation, so 10.08 times 0.877 raised to the x, and you're going to take this 0.0877x. It's really hard to read. Let's try this one. That's a little bit better. And we're going to raise that to, or we're going to write it as the natural log, okay? So what you're going to do is you're going to convert it. So you have y equals 10.08. Then, so this is the change, we're going to put our e in, and then from there, you're just going to put the natural log of 0.877 times x. So the x was already there. Let's write that in the bright green. And so then I would take and plug this value right here into my calculator, which would give me a final answer of y equals 10.08 times e raised to the negative 0.131 x. And so if you were asked to change this to a natural exponential model, this is what you would do, and this is how you would get your answer. And when you plug that into your graphing calculator, it graphs the same, it looks the same, it's just written in a natural exponential model form.